everybody. Welcome to the VM Workshop 2021. Our last session on this first day is Jim Moling from Marriott International. He's going to be talking to us about a cloning methodology for zVM SSI clusters. So over to you, Jim.
Okay, thank you, Bill. And hello, everyone. Let's see if I can get this to go. Okay, there's our disclaimers. So it's all my fault and nobody else's. Okay, that's what I'm going to attempt to cover. And at the end, I do believe I'll have a little bit of a demo to show you, but not as much as I was hoping. See how that goes if we have time for it. See how well it goes here. Okay, so I'll talk about cloning. As the title suggests, that kind of tells us a little bit about what we're cloning, but I can elaborate a little further than what the title has to say. So something to say about that as far as why we're cloning, and then really going to go mostly into how I'm doing the cloning. So hopefully you'll find this interesting enough. Let's see. So after the why, what, how, then I'll touch on just a little bit of our mainframe environment in terms of how significant it plays a part in considerations for cloning. And then I'll go a good bit into naming conventions and standards, because it really is a crucial aspect of this, which hopefully will become clear as we go through it. Then I'll talk about the configuration that I put together that I'm cloning. Then go over an overview of the cloning process, and then an actual step-by-step, of the cloning process from start to finish. And despite all the things I'll be talking about that the cloning process will do, there's still some follow-up actions that need to be taken, which at the very end, when I talk about what's next, I'll be talking about, how maybe I can get it to be even more complete than it is. There's always room for improvement, right? And then we'll see if I can get a little bit of a demo going here before we finish up. Okay, so why cloning? Well, a lot of a couple of good reasons. One is it certainly helps to maintain a standard of your VM configuration, because if you're cloning or copying your VM configuration, then you're also copying those same standards and applying it to the new configuration. So it's easy to carry forward a standard that you put into place that way. But probably the biggest reason is the complexity, right? And an automated cloning process can really help to reduce the complexity by relieving you of all the burden of all the details. And certainly with the introduction of SSI clusters with VM 6.2, definitely brought more complexity to the VM environment, which hopefully you'll get more appreciation of as we go through it. And basically, I gave a presentation, back in 2012, I gave a presentation on cloning VM, but it was much easier in those days. It wasn't too much more than just copying DASD volumes back then compared to what it is now. Really, it's all about the automation of all these pieces that you have to deal with, so that it just avoids you making these potential errors, because there's so many things that you have to keep track of and keep straight. Trying to do it manually is it's become more of a timing thing. So you definitely save a lot of time. It's not as painstaking. So, all right. So what are we cloning? And of course, we're cloning SSI clusters. But there's two flavors of cloning, and I developed them because I needed to do them both. So one is just to clone a new member of an existing SSI cluster. So you have a SSI cluster that has member A, and you want to clone member A to create a member B or C. So that's the easier method of cloning because you're not having to clone everything. You're just cloning what I refer to as a member-specific DASI-VIMEs versus the shared DASI-VIMEs that are SSI-wide, where all members have access to it, versus member-specific, where it belongs to just one particular member of an SSI. So obviously, the converse is cloning the whole SSI, and that means everything. So obviously, that's going to be a little bit more involved. Certainly, more headaches to go along with that as well. So why clone a new SSI cluster? There's a couple good reasons. So maybe you need more than one SSI, one for production, one for test. We have one for production and one for development. And also, it's a great way to upgrade your an SSI cluster based on the VM version it's running at, and I did that. We had an older SSI cluster, and via cloning, I created a new version of that cluster, bringing it up to the level that we're getting stabilized at here, which is 7.1, so that we can then move on up to 7.2. And okay, so also another reason for doing cloning, which I'm also going to be doing at the end of all the cloning process that I have to do, and that's to take the existing 7.1 VM cluster that we have and basically convert that so that it's following the new naming conventions as well as configuration that I've created as part of this cloning process. And so with that, let's move on. So how are we doing this? Most important thing, I think, is establishing standards that will support multiple SSI systems. Of course, you need to have some kind of a naming standard. That pretty much goes without saying, but it becomes very painfully obvious as you get into this with some of the challenges that you face. But needless to say, for the cluster environment itself, having standards, conventions, certainly anything that you want to automate is going to work a lot better if it's based on certain standards and consistencies. So as far as what do you start with? So I have two considerations. One is establishing a base system as a prototype. And that's just alluding to you get a shipped configuration, as I call it, from IBM. You order VM, and they make it available to you, and that's the shipped configuration. You install that, and then you can use that as the basis for the base system from which you can then start cloning additional systems from. So that's kind of what I'm thinking of there with the base system as a prototype. You start with that, and then you just roll with it. Or you already have SSI clusters. You can just take one of your existing ones and start with that. And that's actually what I did in developing this cloning process. So either way works. I've done both ways in the past. So there you go. Develop an automated cloning procedure. Of course, that's what this is all about. And of course, we want to do it in such a way that it's not just unique or special to facilities that I only have available, but it should work for anybody. So to that end, in fact, we don't have some things I would like to have, for example, FlashCal. That's just kind of an expensive option that I have no way to really justify having it here because of the way that we're set up to operate, particularly with mirroring our DASD. So that's just not a component, unfortunately. I missed that because coding was really fast with FlashCal, but still it works. But it's focused on using things that are readily available, namely recs and pipes. And of course, the key utilities, DDR is at the heart of it. That's doing all your cloning for you, basically. And then other utilities have been around for a while, like CP Format XA, and more new utilities that you need now, like Form SSI. So, and we'll be touching on those as I go through this. So, our mainframe environment. And all I want to touch on is that we don't just have VM, right? Of course, you have VM. That probably means you already have Linux. That's not the only reason for having VM. In fact, VM's been around Marriott for so long, it was way before Linux ever showed up in the mainframe. And it was needed for supporting our TPF environments. And as I'm showing there, we've also got ZOS. And so we have 4 operating systems with very different needs and characteristics running on our mainframe. So with such a varied environment, that makes all the more a good reason for having good naming conventions so that you don't step on each other. Particularly when you have some sensitivities. For example, ZOS sees all the VM DASD when it's IPLing, and it does, well, not that it doesn't like or tolerate duplicate Volcers. The operators don't like having to respond to all the messages. If you have a lot of duplicate Volcers, VM volumes, they get asked for every single duplicate, which one should I bring online to ZOS? Not a lot of fun. So I have to be careful about that. So anyway, yeah, it just all suggests that, strongly suggests we've got to really keep track of what we're doing, make sure that we keep things well segregated so that nobody gets in anybody else's way, basically. And as far as VM environments go, we've got a fairly good mix. We have both SSI and non-SSI VM systems. My goal is when I'm done with all the upgrading and leveling out that we're in a much more consistent kind of environment, more SSI-like, even if it's a single image, single system SSI. But we're on the way there, not quite all the way there yet. So plenty of opportunities for me to continue to develop and enhance this process, and we'll be talking about some of those things at the end. So what do we have in our VM environment? Some of the things that we, key things that we have that are common across all of them are security and directory management. We're using both shared file systems and mini disks in our configuration, so it's sort of a good mix of things, I'd say. So as I'm indicating here, VM 7.1, as I kind of already alluded to, is the version that I developed this cloning process under. But I would like it to be able to handle older VM systems as well. At the moment, it's just focused on the SSI clusters. So anybody that wants to use it for something that predates SSIs, this isn't really the way to go. Maybe my older cloning process would be a better bet for that if it's prior to 6.2. Anyway, so, and as I've already kind of alluded to, I've already used cloning to upgrade an old VM SSI cluster to 7.1, and also going to use it to change an existing 7.1's configuration to be in line with the clone configuration, which I'll be getting to next, I think. Well, coming up close. Okay. So start talking about some of the naming conventions and standards. First thing to talk about is the system name, right? So, and what's in a name? It's all the same kind of a deal here, right? Before, SSIs used to refer to a VM system by its system ID or sysid. Now it's called a member name. It's still the same thing, basically, but you know, it's being a member of an SSI gives it a bit more. It suggests a bit more than just a you know, the standalone kind of, you know, single system that it used to be. So as a convention, it just made sense to me that when coming up with a name, that the name of the SSI name, which is new for clusters, make that a prefix of the member name, which is also the system ID. And as I'm showing the example here, if the SSI name is PRD SSI, then the member names will be PRD SSI A1, B1, C1, D1. Now what that means is the SSI name is limited to 6 characters, even though it supports up to 8 alphanumerics. But limiting it to 6 allows it to be used as a prefix, and then you have some consistency here. And it just makes sense to me. So as long as it works for me, I'm going to do it this way. I like it. You know, moving on from that, the naming standard needs to be able to keep the VM systems unique, not just at the cluster level, but also at the Volca level. And that's where the real challenge is, particularly when you consider there's 2 flavors of system volumes in an SSI cluster. What I call shared and member specific. Can't say for sure if that's in the documentation that way, but that's the way I think of it. And of course, the big challenge is that as many years as computers have been around, and the DASI technology has persisted for so long, the Volcers for DASI haven't changed. There's still only 6 alphanumerics, so it becomes a bigger challenge to try to keep all this stuff straight with just 6 positions. And I'm going to go through an example naming convention that you know, hopefully addresses all the needs. So here we go. So getting a little more specifics on the SSI name and member name. So as I'm breaking it down, looking at that 6-character SSI name, breaking that into 2 groups of 3 characters, a prefix and a suffix, right? And that works for me, and probably won't work for everybody, but again, you know, you try to keep it as straightforward as you can. I think it gets complicated enough as you'll see moving on. But basically, 3 characters, and it's a common thread, so everything kind of ties together. But the 3 characters here as a prefix allude to the environment, right? PRD for production, DEV for development, TST for testing, etc. And then, geez, stop this. Okay, sorry about that. And so then the SSI is just a literal for the suffix of the SSI name, and very conveniently says what it is. We have, like I said, non-SSI VM systems. It's easy to tell the SSI VM systems because they got SSI in the name. So because I can do it, I do. It works. So that's the format. Basically, you have the first three characters indicating the environment, which also tells you what this SSI cluster is for: production, dev, test, what have you. And then the suffix is going to indicate the member ID, the member name. You know, the ID being A, B, C, D, and then there's a numeric suffix. It's always been a 1, but I suspect it's there so that you can alternatively use a 2 if you need to, perhaps during some transitional processes or whatnot. But anyway, that's the naming convention for that. So moving on, now we're going to take a look at the Volca format. So like I said, we've got six positions to work with. So again, I'm breaking it up, splitting it up into a 3-character prefix and a suffix. 3-character prefix is fairly fixed, static. It's the suffix that gets a little bit interesting, I guess we should say. So the 3-character Volca prefix, with those 3 characters, it can tell you is this a VM volume and what the environment of that volume belongs to, and whether or not that volume is a shared or a member specific type of volume. And as I'm showing there, it kind of lines up. So the common prefix for VM volumes is a Z. So any volume that starts with a Z is for VM. And nobody else should be using except VM. All right, and then the second position, it's going to be the environment. So D for prod, D for dev, T for test. So that correlates, right? You have a 1 character that correlates to the 3 characters and goes from there. So, and the category, the third position, is basically, it's going to be an S if it's shared, or it's going to be the member ID, A, B, C, or D in this case. And I know that with newer versions of VM 7.2, that limit of 4 members will be expanded. But for now, that works. Oops, a little ahead too quick. So 3-character suffixes, it's kind of transitional, as we'll see. So the standard indicators are that the 4th, 5th, and 6th, right, is type, subtype, and the last position is numeric. The idea is that for the naming convention, you can use up to 5 of the 6, but you need to have at least 1 position to allow you to have more than one of those things, right? Whatever those 5 characters are describing, in some cases you only have 1, and we take advantage of that in how we're using the naming convention. But so at the very least, you can have, as it shows here, 0 to Fox or 16 versions or different iterations of that particular type of volume. And actually, you can go up to 36 if you go to the end of the alphabet. So, you can, even though it's somewhat limited, it certainly hasn't been a limiting factor anything that I've worked with so far. Okay, so here's an example. Here's some examples. So this is we're now looking at the shared volume side of the naming convention. So when that third position, the C category position, is an S, then it's a shared volume. And so when that's an S, then the fourth position, which is the type, it's either going to be a C for common, an R for release, a U for a user volume, or an I for an ISV or a vendor volume. And then you can see the examples here that I provided. So for a common volume, you can see that all of these volumes, actually, if you look at them, they all have the same common prefix, ZPS, right? Z for VM, P for production, S for shared, C is for common, R over here is for release. And you have these three flavors of vendor volumes down here that I've given as examples, and then a user volume. So as this is showing, now, one of the things I always like to take advantage of, you only have one common volume and one release volume, so long as it's big enough, in a given SSI cluster. So by making sure that you just have one of those volumes, then those last two positions can be used to advantage to indicate the version of VM that this volume is for. So in the case of the common and release, just looking at those vol spheres, you know that, oh, that's for VM 7.1. So you can look at the vol spheres of a collection of DASD volumes, and you can tell a lot by just looking at that, the way the naming convention works out. So when it comes to like the user volume, because you have a double zero at the end, it only needs a U to make it unique. So you can have up to 256 if you stick with hex user volumes, which I think already is way more than I'll ever need. So, you know, in terms of being limited by the number of a type of volume, I don't think that's going to be an issue with this naming convention either. Looking at the vendor volumes, I decided to separate out vendor software to their own volumes. And so this is the shared flavor of the volumes. And as you can see, I have one for Broadcom for the VM suite, IBM for IBM software that isn't already included with VM that you would install, would go on one of these volumes. And then one for Velocity software, performance suite. Could be others. I'm actually not using all three of those. These are just examples, but just to kind of illustrate the point, right? That you can manage it like this. And there's great advantage to being able to have things separated out. And hopefully that'll become clear as we go further along. Okay, so let's move on. Now we're at the member-specific side. So now the third position is a member, and as I'm showing here in the red at the top of each of these example volumes, these are all member A volumes. And lo and behold, the third position is an A. So Z for VM, P for production, A for member A, and then what follows after that can be more of a variety than what on the shared side of the house. And as it shows here for the type, it can be either a sysres, residence volume, a spool volume, a page volume, a TDIS, temporary disk volume, a user volume again, but this is at the member specific level, and an ISV or vendor volume again at the member specific level. So the residence volume is following the same kind of convention as the common and release volumes on the shared side, where you only have one residence volume, again, if it's big enough. When it's not big enough in the past, you would have additional work volumes that it would kind of flow over to. But my intention is always to have a single volume where it can be done. So, so with sysres, it's always going to be a single volume. So R for sysres and the version 7.1. So you know what that's what version VM that's for. Again, the spool and looking at spool and then page and tdisk, they both have double zeros at the end, so you can have a lot of those guys. In particular, the one that really might become cramped for space as you grow in terms of memory footprint is the paging volumes. Fortunately, larger page volumes are supported these days, and I'm starting to push up the number of page volumes with the size of parts that we're running these days. But it's still a workable framework with that. And the type of dump volumes that I'm focused on here in these examples are dedicated spool volumes that are for dump purposes only. So that's why you'll look at the dump volume, look at the spool volume. It's the same, the first 4 characters, because it is a spool volume, but it has that additional D for dump in that 5th position. So, gee, that means we only got room for 16 dump volumes. Well, these are mod 54s to begin with, and they could be even bigger eventually. So I think I've got enough dump volumes. I certainly haven't had so many dumps that that's been a concern, and hopefully that'll never be a concern. But anyway, there you go. We got plenty of dump space. And of course, in addition to this, I could create, you know, just a standard perm space volume, which would be like the user volume, but just dedicate that to dump space as well, which is not a spool volume, but it would be like a special purpose user volume just for dumps. So, but at this point, I haven't had a need for that. Okay, so that's the sort of little twist with spool, is that you have that the dump volume that's sort of a split off of that. But again, it's all under the classification of spool volumes. And with page tdisk and user volumes, you can have a bunch of those, right? So, okay. And again, with the vendor volumes, works the same way. It's just the difference is that 3rd position is an A, B, C, or D versus an S. But you can have the vendor volumes unique in each scenario this way. And with vendor volumes, you know, certainly a mod 54 would be overkill for, at least in my case, for some of these. You just use whatever size you can carve out that's available. Even a mod 1 would be enough in some cases, but and you know, mod 1 at 3390 mod 1, that's almost unheard of anymore. But yeah, it can be done. Okay, let's see. Moving on. So basically, what I'm saying here is, with respect to the 2 different flavors of DASI volumes that we have, and what I'm trying to say here is, and it could be misleading depending on how you read this. So for any given volume, if someone has rewrite access to it, it kind of locks out anybody else from having more than just this read-only access. And depending on, you know, while you're in the middle of updating it, even read-only access by somebody else can be questionable, right? Unreliable. But what I'm saying here is trying to make a distinction between a shared volume versus a member-specific volume. So with a shared volume, so say I have a user ID Jim on member A and a user ID Jim on member B, right? And if it's a shared volume, I can get to that volume, to a mini disk on that volume from a user ID on either of those members. Member A or member B can can access that volume, but whoever accesses it first could get it for read-write, and the other one could only get it for read-only. That's the way it works on at the shared level of an SSI cluster. Versus a member-specific volume, it's only going to be available and seen by user IDs of a particular SSI member, right? So if it's for member A, Jim on member A can have a disk on it. Jim on member B, he's not going to see it, not going to have anything to do with it. But even still, though it's only on member A, yeah, you still have to consider that only one person can have rewrite access to it, because you got multiple users on that one member, right? So I'm just trying to make the distinction between the sort of the scope of access that shared versus member specific has there. Okay, so it's like cloning is based on the IBM ship configuration plus some additional volumes, as you've already seen, right? I've added these user volumes, and that's something that I've been doing for a long time. But more recent twist is these ISV, or which is independent software vendor, if you're wondering, and or vendor volumes, right? Again, to help manage the those types of entities, and it gives you some more flexibility there. So basically, with user and ISV volumes, as we've seen, you have them both on the shared and the member level side. But a T-disk and dump volumes, those are going to be basically member specific, right? So you want to have one for all your members. You're going to have separate space for each one, dedicated space. Okay, so this kind of shows you, okay, up here at the top, these are the volumes that you get when you install the ship configuration. And really, you only have data on 3 volumes, these 3 here. I don't know, can you see my cursor moving around?
Yes, I can.
Okay, so I don't know if that's just me or if you can follow. So you've got data on the common release and sysres volumes that are installed from the shift configuration, right? And the spool and page volumes start off just being formatted empty space, but you need them. They're essential. Can't bring VM up without them. And heaven forbid if you run out of space on one of those volumes. You don't want that to happen either. So that's part of the care and feeding of VM, right? But as you can see, I've added quite a few additional volumes in the bottom half here. Looks like we got 10. We're adding 10, right? So this whole thing becomes the cloning configuration, as I'm calling it, right? So if I have an SSI cluster that doesn't have those additional vendor volumes or T-disk or user volumes, well, those are going to be new when I first create the clone, the cluster replacement. Those guys aren't going to have anything on them. So when you're cloning them, you're just going to format those just like you would the ship, spool, and page volume, right? First time around. But after you created that new cluster and now you want to create another member from it, well, now all those volumes should have something on it, because the intent was you're going to split things out and propagate things on these new volumes that you've added to the configuration. So now you've got to do more than just format. You have to copy the data just like you do for the common release and sysres of the original shift configuration. So it changes, how you clone changes depending on the situation. Just want to point that out. That's one of the considerations that we have to take when we're cloning something. What is it we're where we're coming from and where we're going to. Okay. So preparing for cloning, and this is something that I recommend doing since I've almost started doing cloning, and certainly back in 2012, when I was talking about cloning then, you know what, the idea of setting up a dedicated virtual machine for it just made sense. The VM cloner ID that I'm talking about here, give it all the special privileges it needs for all the various things it has to be able to do, not only just for cloning a new VM environment, but also to be able to IPL that VM environment within that VM cloner environment, virtual machine, right? And that's second level VM, right? As I'm saying here, to be able to bring up this new clone system in its own sort of enclosed environment so you can check it out and see if everything's okay without hurting anything else. So in isolation, as it were, right? That's the nice thing about being able to do that. So I only got 3 programs in order to do this. The main program is this Clone SSI program, Rex program. That thing is getting close to 3,000 lines of code. I think it's about 2,600 lines right now. So it's got quite a lot going on in there. And you know, it's the brains of the outfit. And part of what it does, as I'm saying here, it's a step 1 of a 2-step process, because it figures everything out, and then it creates another Rex program that you run to actually do all the steps. So it just, as I was working and developing this, it seemed like a prudent thing to do, just from the standpoint of making sure that I got things right. You know, create something that is independent of what it's doing, so that I can look at the results of what it did before I actually do it. Okay, and that was very helpful. That's especially helpful in the development phase of this, but it also is just, it's a good like safety check to be able to make sure that you're using the volumes you specified in the right way, that you didn't mix anything up. You can kind of more easily spot it when you see how it's actually going to use these volumes, which ones it's formatting, which ones it's copying, etc. Right? And again, depending on the situation, one case it should just format it. In other cases, it's got to copy data. So, okay. So, and what it does is it reads an input file that gives it the minimalist amount of data that I could think that would be required in order to be able to do this without getting too overburdened with lots of details. I mean, it'll try and figure out a lot for you, but you know, if you don't like some of the defaults and the way it handles it, well, you can change that too, and we'll get into that. Okay, so it reads the input file to get all the details for the new target system that you want to clone, and it creates this Rex program. And the way it creates the name, it'll always start with SSI, which is the converse of what it is. It's Clone SSI, and what it creates is going to be SSI something. And that something is, again, based on that naming convention. If your SSI name is PRD SSI and the member is B, well, then the exec it's going to produce is SSI PRD B. So kind of makes sense, right? So that's the way I've set that up to work. So as I'm saying here at the last line, after that Rex program is created, you can take a look at it. It has comments in it that describes what it's going to do, and at the top, and then it goes into a middle section where you're basically sort of seeing what it's doing, and then it has all these subroutines that actually do all the work that after the middle section, so to speak, right? So the middle section, top and the middle section allow you to kind of clearly see what it's doing with what volumes, and you can quickly see if there's something not right. So it's not like you're looking at this convoluted code and trying to figure out, well, is this right or is that right? It's fairly easy to see the way I designed it. So, okay, moving along. So the first program was the Clon SSI, and the second program is the one that it creates, that SSI PRDB in that example. The third program is the IPLVM program, which has been around a long time. I had that back in 2012. That's what's used to IPL the system after you've cloned it, see if it works. So keep that down, those programs down to a bare minimum, but even if they do kind of do a lot. So there's, as I've already talked about, there's two cloning options. One is just to clone a new member of an active SSI cluster. You know, you've got a SSI cluster with member A, and you want to clone a member B. That's got to be easier because you're only going to clone the member-specific volume, which is a subset of the whole cluster, right? And of course, the other option is to do the full mining, to do the whole thing. And of course, that's going to be, you know, a lot more involved, and it also takes some more time because you got more volumes to deal with there. Okay, so okay, overview of the cloning process. So the first thing we got to do is basically just copy it from source to target volumes, right? Well, as someone often says, it depends, right? So some DASI volumes are always going to be copied, right? Like your common PDR. PDR is another way to reference the common volume because the common volume has something on it called a PDR, persistent data record. So it's interchangeable. I typically kind of refer to as a common volume more so than the PDR volume. Sort of a tomato thing, I guess, right? So yeah, you've got the common, you've got the release, and you got the residence volumes. Residence meaning the sysres. You have one for each member of an SSI cluster, whereas the common and release volumes are the shared volumes. But in every case, yeah, if you're going to clone those volumes, you got to clone them. It's not going to be a knit as an empty volume, right? However, depending on what you're cloning, the common PDR volume and release volumes may not be copied because they may not be included. Okay, so there's always but an exception there. Some DASI volumes are always formatted, and that's going to stay pretty much true, right? Page volumes, spool volumes, the spool dump volumes, and the TDIS volumes, those are always going to be formatted, right? As I'm indicating here in parentheses, a page volume is formatted with, you know, as page space, and a spool volume is formatted with as spool space, SPOL, and a temporary disk as TDSK, right? Those are the formatting types, and you know they're different from each other, right? So they have to be done that way. Then you have some volumes which are either copied or formatted, and again, it depends, right? If like I was saying before, if you're adding a user or vendor volume for the first time, you got to format it, right? It's empty. But if it's already there, well, now you want to make a copy of it if you're going to clone, right? So, you know, again, so the exec has to, the clone SSI exec has to be able to determine, you know, what fits the scenario, right? So it's got some things to figure out. Of course, if you're only cloning a new member of an SSI, then of course the shared volumes are not going to be copied. So that means you're never going to, if you're just cloning a member, you're never going to do the common release or the shared user and vendor volumes, right? That share side just gets left alone. All right, so now, so if you're doing a full SSI cluster, after you've copied all the volumes, remember I just mentioned about this persistent data record, the PDR. On the new clone common volume that you just created, you've got to create a new PDR on there, because guess what? It's reflecting the SSI cluster you just cloned from. That's no good for the new cluster that you're trying to create. So you have to be able to basically replace that with a new one that has the correct information in it. And this PDR is key to having the SSI cluster operate, properly. The common volume is a key volume in that respect, right? For other reasons as well. That's a good reason for it. And as I'm saying here, there's a particular utility, Form SSI, that's used to create this PDR. And I'm showing the example here where you would plug in the address of the DASI volume for your new cloned common volume, right? And you have to use a force option because there's already something out there, right? That's what force is for, I guess. I know it doesn't work if you don't use force. So, if you're creating one from scratch, then you probably don't need that, but that's a whole different scenario that doesn't apply. And there is a display option of the Form SSI command, so you can use that to verify the results. You can also take a look at it before you actually create that new PDR to see what it looks like before you do anything to it. And you'll see, lo and behold, hey, that looks got all the information of the old SSI I just cloned from. Well, that makes sense. So yeah, those commands are helpful, but these things are going to be executed as part of the Clone SSI process too. But you could do these independently if you wanted to take a look. Certainly the display, right? Okay, so once you've got that taken care of, then whether you're doing a member specific or the whole SSI cluster, you have to update what's called the ownership information on all the volumes that are CP owned. Okay, CP owned volumes. Most, not all of it, but many of the volumes that we're dealing with here are CP owned. And for CP owned volume, you have to. They've enhanced the CP Format XA command. Didn't used to have this, but it does now. It has these owner fields for the SSI name and the member name. And I'm showing the example where both of those are used, which is a residence volume, right? And I can see by looking at this false here that, oh, okay, this is a zVM production member A sysres volume that's VM 7.1. And it's because even looking at that vol here, I know it better have an SSI name of PRD SSI because that equates to the P, and PRD SSI A1 better be the member name because that equates to the fact that it's indicating this is a member residence volume versus a B, C, or D, right? So with the naming convention, you can see how things connect together, and it helps keep you from making the mistake of using the wrong residence volume for a member or something, right? Okay, so updating the share volumes for this ownership information is only applicable if you're doing the full SSI cluster clone, right? Which means the common and the release volumes. But for member volumes, they're common no matter what you're cloning, right? So you're always going to have to do the Redis volume, the spool, the page, and the tdisk volumes. Those are all CPU-owned volumes, and they need to have that owner information updated. So the program will figure that out, and it will do that. Okay. And oh, by the way, even if you specify in the input file criteria for the shared volumes, doesn't mean that the Clone SSI program is going to act on that. Oh, you define those volumes, so I'm going to go ahead and do those. It's going to figure out whether or not it should actually do anything with them, and if it's not, doesn't need the shared volumes, it'll just ignore them. Okay, that's one of the things that I want to make sure you couldn't get yourself into trouble by specifying something you shouldn't have. It shouldn't matter what you specify; it should know what to do, and that's the way it works. Okay, so now after you've taken care of all those housekeeping chores with the volumes that you've either copied or formatted, what have you, now there's a couple of key files that you have to address. System config is the first one here, and there'll be a diagram coming up at the end of this where you kind of see, it'll make a little more sense with the picture. But anyway, system config is owned by the PMA ID at farm disk CF0. And so, as a convention, again, this is just to make sure you don't step on feet or whatever, any kind of naming conflicts. If you're always using system config, something's going to clash with something, right? So I suggest, okay, let's change system to the SSI name. So if the SSI name is PRD SSI, then the system config file, make a copy of it and call that PRD SSI. And you can basically IPL and specify PRD SSI config, even though it might default to system config. But then we can also make it so it'll default to PRD SSI config by updating the, well, we'll get into that. But you can make it all jive out. So it's not like you have a weird anomaly by doing that. You can make it part of the process, which is what I did. So once you create the copy, then you edit it, and then you have to update various things depending on what kind of a clone did you do. Did you do a full cluster SSI clone, or did you just do a member clone? If you did the full clone, then you got to update the SSI name and the shared volume specified in the system config file. But if you're just adding another member, that information should already be there and should already be correct. You just have to basically add a new member into this configuration file, specify things correctly for that. And this is what the program will do for you. And of course, if you have new things that you're introducing into the configuration, like user volumes, vendor volumes, they got to be added in there as well, just so that they'll be brought online properly, when the system comes up. So that's addressed as well. And just to mention, I'm not going to go into this in any depth here, but just to mention that another consideration for the system config is the inter-system links, or ISLinks, I guess. And these are CDC, which is channel-to-channel connections, which is the way that members of an SSI cluster talk to each other. Now, if you just have one member SSI cluster, you don't have to worry about talking to anybody. So you don't really have to worry about these inter-system links, right? Only until you're going to have two or more members does that really come into play, right? So that's why I'm saying you need it if you're cloning a new member. Otherwise, you can do it later. But later means if you're cloning the whole SSI now with member A, before you go to do member B, it would be wise to do the work you need to to figure out what CDC links you're going to use for these systems to talk to each other. Now, there is a way to test it out without actually doing that, because there is a virtual CDC, and because you can bring up VM second level, right? You can use the virtual construct and actually have two VMs running second level and have them connect and talk to each other using virtual CDC connectivity. So you can actually test that out to see that it works and that these two members can talk to each other. Then when you go to translate it into, bring them up into real LPARs and see if they talk to each other. And if it doesn't work, well, you know it's nothing wrong with the VM systems because you figured out how to get them to work second level under VM, right? So that's sort of a good thing to be able to know, to do when you're getting into that. But that's all I'm going to say on that, because that's not the focus of this presentation, and that can be a whole nother presentation, I think. Okay, moving on. So the next key file that we have to address is the VM directory. The VM directory, not quite as simple as the system config, because you have two forms of the VM directory. You got the source directory, and then you have the version of the directory that's used by CP, let's put it that way, right? So, and to complicate it further, if you're using a directory manager like Dermate or VM Secure or something else, right? Yeah, it puts another little wrinkle into it. You have to find out what the procedure is for, depending on what you have, to create a source file of the VM directory. Because typically with Dermate or VM Secure, it has its own internal way of managing the directory, and you don't have this monolithic source file that you can look at it as say, when you first install that ship configuration, and you have this monolithic user direct file with everything in it, and as soon as you introduce a directory manager, that kind of goes out the window. So you have to open the window and bring it back, right? So that you can, at least for the purposes of getting the system up and running, you need to be able to go back to the manual method of using the VM directory and putting it out in usable form for CP, the control program of VM, to be able to use it to get the system up and running. Once you've done that, then you can plug back in your directory manager. And again, there's procedures documented for a particular product on how to do that you can follow. I'm familiar with what it takes to do that for Dermate and VM Secure. Coincidentally, those are the two that I list there, right? Of course, we have VM Secure, but I've worked with Dermate in the past, so I know their particular requirements. But there could be other things out there that I don't know. So, anyway, so okay, so again, the same naming convention change. The default name for the VM directory file is user direct. And again, I'm suggesting PRD SSI direct, for example, again, to keep it unique so it doesn't step on anything else. And I'm describing what you need to do to put that out on the sysres volumes so that CP can use it using this directxa command. And this is, again, done by the program, so, but you could follow this sort of basic script here to do that if you needed to. It's just informational. Okay, here's that picture I was talking about. And this kind of shows the key areas. And over here, we just sort of just show a quick flow from starting at the LPAR level to do an IPL load clear of the address of your sysres volume. And that's going to point it and load up the sample program that's here in the Bootstrap records. The standalone program loader is where, Bootstrap point to it and then it loads that and runs that, and that presents a screen to allow you to customize how you want VM to come up. And this happens before it then, and once you tell SAPL to go, it then loads the CPU load module, which gets VM up and running. And once VM, the CP starts running, it then reads the system config and goes on from there. And then these directory blocks that you needed to get out there come into play when you want to log onto the system. So there you go. That's how it all ties together. Those are important thoughts. You got to get those things in place or you won't be able to get your system up and get into it. All right, so, and then the other thing I just touched on, the SAPL. I have a program that I wrote and it's incorporated into the Clon SSI that will update that SAPL configuration so that it will know to use that different name for your system config, to use prod SSI config, for example. Okay, and then in order to use the IPL VM exec, I mentioned a couple of things here, which are also explained in the information I include in the cloning package of how you need to define the system so you can use that exec to bring it up. Okay, so now this process, we're going to go through from start to finish what happens to actually do the cloning process, and we'll just skip through this because I'm out of time. But you log on to the VM cloner ID, which you set up, right? And then you execute the Clon SSI program, reads the defaults, and then it reads the Clon SSI input file and goes from there. Does all these things. And then you get to a point where it does an analysis and displays this message. It tells you what it figured out. So it figured out what your source is and what your target is. And if the source and target SSI name are the same, well, then you better be doing a member clone, right? Especially if the member ID on the source is A and the target is something other than A. So couple things it won't like if you have dev SSI A here and you have dev SSI A here, like to like, it's not going to like that. That doesn't make sense to it. Don't think that should happen. And why would you? You're trying to. It's like you're trying to write over the system that you're running on. Not a good idea. Okay. So there's a log file that's created. Look at that log file to see how the results went. And then basically let you know, okay, should I execute that program that it created or not? And then the steps that are executed by that program that was created are listed here. There's 12 of steps, okay? Once you get through that, then you're ready to IPL second level. And then there are these post-IPO actions that you have to take. And I don't really have time to talk about that, but these are fairly well described. So, and these are things you have to manually do. So after you clone your system and you IPL it, IPL that system second level, you log into it, and then you take these steps to follow up on additional steps that need to be taken in order to complete the transition process to the new member or SSI cluster, right? Okay, that's all these things. Okay, so it's a bit of a rough start, I say, because there's a lot of moving parts and a lot to figure out. I'm working on developing some ISPF-like panels for both displaying the results of system query information to show you what it sees that you have out there, so that you can see that it agrees, and also to make it easier to enter the data, you can have data input panels to key into, as opposed to updating a file and possibly doing finger checks and whatever, right? Make it a little more reliable. Also, hopefully I can automate more of those post-IPL actions so that maybe there won't be any. And eventually wanted to be able to clone non-SSI VM systems. It's not even thinking about that right now. And I will submit the cloning package to the VM Workshop website, so you can grab it from there and give it a try if you want. And with that, I'm done. There's no questions. Happy cloning.
That was great. I know there was a lot of things to consider in something like that, so
Yeah.
I appreciate it.
Well, thank you for the opportunity to talk about it.
Sure. And we'll have to pencil you in for next year, since it sounds like you'll have more to talk about then.
Oh yeah. Hopefully, we'll see a lot of improvement between now and next year.